As an architect, we would feel very informed to have energy data very early in the design phase. That's when we're able to make the most impact on the buildings we're designing. To have that data early requires energy modeling. So trying to figure out how best to obtain that data has been somewhat of a challenge. We're architects, and to integrate energy modeling into our workflow can be somewhat challenging. We've had some successes in doing that, energy modeling internally. Other avenues to achieve obtaining that data is working with engineers perhaps earlier than we're accustomed to. We've also started to take advantage of the utility incentive programs, which also offers early phase energy modeling. Really what we're after is, at a very high level, trying to figure out how to have data that can inform us which option in a design is better than the next. So for example, if you're designing an office building, knowing how those early design sketches of office buildings are performing relative to each other would be very helpful.
Well, I find it interesting, I'll say first of all, that the conversations that we're having today are the same conversations that we've been having for 15 years with similar answers as well. The development of engineers and architects has come a long way. Really the successes have been in pushing people towards away from rules of thumb to saying design really should be design, as Vikram said, something that's an action word. Pushing back to get people to think more in systems thinking rather than a linear process, asking engineers questions like, okay, I just need a shoebox model. You don't need to drill it down to every mullion. We want to do order of magnitude, and challenging people to do that, having success and increasing success over time where people are really getting that concept.
One of the big challenges is one of the major building types we do is high-rise residential. And there's very little data about it compared to some other building types like schools or office buildings. So I still feel like for that building type, we're at the beginning of trying to understand what's a reasonable goal. We're starting to get there. There's now Energy Star for multifamily buildings, and so we're starting to get data. But it still feels like in that area very new. For some of our campus buildings, there's more benchmarks and things we can compare it to, but that's definitely just data. We're really hungry for that in the beginning of a project.
Beyond people embracing the idea of more high-performance building design, it's how do we do this? And frankly, it's numbers. And that's measurement and verification. How do we do this? Energy modeling. You have to energy model, you have to energy model, you have to energy model. I think, unfortunately, a lot of the design community isn't quite sure what the heck that means. I don't know how to do this. I don't know how to start. I don't know who to turn to. What are the programs I should use? And there's a difference between having data and having information. So I think that's kind of a lot of what we're trying to sort out in communicating to our readers and the people who are trying to figure this out. And one of the really fascinating other takeaways I took from this conference, there was a professor from Catholic University at Washington, D.C., who said that before you can even energy model, there needs to be a much more upfront data analysis. And even Vikram in his presentation talked about before you even get to the energy modeling point, it's about putting X amount of information into the model so that the team could actually have positive feedback in an early enough stage so that the model can actually be useful. Otherwise, it's just an exercise. So I think that part of this process is identifying how do you figure out what kind of information I need to get by asking a lot of very simple questions. I saw a case study kind of along this process, and it was really fascinating because It was a pretty nondescript building in Portland, the 70s era federal building, office building, nothing to write home about. And they were doing a significant energy remodeling because obviously they wanted to improve the efficiency of the building. But they had also brought on a designer that was known for creating some very interesting kind of biophilic design. But the team talked about how they had to hold this guy almost on a leash because they wanted to do all the analysis before they started the process. And that meant studying how the sun is affecting the building during different times of the day. What about the rest of the buildings in the neighborhood, in the area? How is that affecting the shading or whatnot? So they wanted to really figure out, they wanted to get all this really good positive number, analyze it, figure it out, then do something about it. And what ended up being a great win-win for this building is that this designer, after they had fed him all this information, came up with this really interesting looking sunscreen that was primarily designed obviously to stop the solar gain from the west sun that the building faced in its elevation, but it ended up becoming this very interesting, almost beautiful facade element. So this building was transformed from being kind of this ugly duckling to a beautiful swan, but hey, guess what? It also was much more energy efficient, and it was because of this whole data analysis process. And it really, I think that is a new chapter that the A&E world is coming aware of right now, that I didn't have to think about this stuff before. I didn't care about this stuff before. Now I do.